This is a demo of learning the model context protocol. And in order to do that, I wanted to build an interactive demo while I was learning in order to learn it. So I used Windsurf and built a little interactive prototype so you could see this thing actually working. So what happens here if we reset this? I think my key will still be in there. No, it's gone. I gotta put my key back in there. 1 second. Where is it? MCP. It's in my file. See, there it is. Okay, here's a demonstration of learning model context protocol. And by explaining this back to an audience, I hope that other people can learn it. And I learn by teaching others. And I realize I learn faster by building. So if I interact with something and I build it, and then I have to get a deeper understanding of it. So what I've done is try to learn even how LLMs or large language models are really just models. This is my own perspective and what I've taken away since my first discovery with ChatGPT is like, well, how is this magic working? And I've got an idea that I think helps me understand it, which is that we know that it is an emulation of sort of how neural networks behave. And that means I started to really go into learning more about mental models. And this video here, anybody can access on YouTube from the Cabrera Lab podcast called Systems Thinking, a little film about big ideas. This is such a good video for anybody who wants to learn about mental models, because this will give you an idea into how thinking works and is shaped so that you can see the relationship between large language models or AI models and human models, which are mental models, right? And if we are emulating human neural networks, well, what is going on there? So that's a video for anybody who's non-technical to get an understanding of what a mental model is. And that means like we all have different context about everyday life. So in this video, as you'll see, I don't want to give it all away, but if you watch it, she walks by this dog. She has a different impression leading into this experience. And then there's another guy in this video that if you watch it, you'll see he walks by the dog, and they both have different mental models of their impression. The dog is there, and one person's entire history of the relationship of dogs is different than the other person. One person may have been bitten by a dog when they're a kid, the other isn't. So as they walk by, this video does a really good job of showing two different mental models of the exact same thing they're looking at, which is a dog. And that helps us see that each perspective, how we view the world, is our own biased interpretation of the exact same events in front of both people. Same dog, but different relationships about how you're thinking about that dog. And then this other video is really good as well, that talks about from infancy to how your neurons grow and become a network. And then I believe this is a really good way for non-technical people or even technical people to sort of get a picture of how the mental models work, so that you can realize that you are just a walking model, right? Every experience in your life is shaping how you think and respond to the world around you. And this is unique to every human being. We all have a very biased perspective of the world and how we interpret information. So we're walking mental models everywhere we go. And if I was to ask you to tell me a story about dogs, you're going to tell me a very different story than somebody else, right? You use all your life experiences to tell me a story about dogs. And that's basically the training data you have. So you're growing up, and all the events that you've ever had associated with dogs are basically your neurons that have stored memories about it. Were they good experiences or not good experiences? Were they bad, positive? So that's your training data. You have a unique training data on all the experiences with dogs. And if I ask you to tell me a story, you tell me a story based on your perspective, which is really, really cool. You got very unique individual mental models about the world. So now let's sort of pivot over to what's happening with AIs, or large language models, which it's basically that word is under the hood, right? A model. All models are wrong. Some are useful. I love that saying. And that implies that they're representations of an abstracted representation of the world. So in the same way that two people seeing this dog have different stories and perspectives of what they're looking at, that shows you that if I was to ask facts about dogs and I only took one perspective and not the other, I wouldn't have enough information about dogs in general. If I was a complete alien and I just landed on the planet and I just talked to one person, I would only get one mental model of what a dog is. And that's just not enough information. So models are just abstracted ways to sort of get a general picture and sense of something, but they are so they're useful. I like thinking about models that way, so you don't get fixated on truth or absolutism. So when we say, there's like ChatGPT or Grok or all these other LLMs or AIs, what I think is a mental model that helps people see the relationship to neural networks is that if you think about this image here to say that, well, what if we could take a computer and put all of the world's books into the computer? And then I was able to ask the book about something. It would be able to go through this information and find, if this was the only room it had of books, it may not be all the books in the world. So that's a way to say that, let's just take, for example, that Grok had access to this building and these were the books that it had. You could then say it has a model of information. This is the information it has. And it obviously has way more, but just for simplicity's sake, I'm trying to draw a picture to then say, well, ChatGPT might not have trained on the exact same room of books, so it has a different one, and it's a little bit different. Maybe they do have the same copies of all these books, but they happen to have more in the other room, and then Grok had a little bit more of a different section in their library. So they're nuanced, and they end up actually becoming a lot like human mental models. So these AIs have their own sort of identities. They are trained on data. The data they are trained on are not all identical. So Grok would have trained on a data set that is not identical to ChatGPT, and therefore when you talk to them, just like if you were to talk to a human, you get different responses, right? And as well as you can start to see that with timelines. When it was first come out, it would say, I don't have enough data. I've only been trained up to a certain point. It means it just hasn't went out and scraped more books. So that's just a general sense of how I draw the correlation between mental models and AI models. And then from there, we've learned that, and then getting to model context protocol servers. This was my learning adventure this weekend, and I wanted to really understand it. So I had to dive into it. And I needed to go back to sort of see this in order to understand why this has so much value. And when I started playing with it, I was like, this is the same as an agentic flow. And we'll get into why why I say that in a minute. But nonetheless, I was like, this has a similar pattern, but I'll explain what I think the nuance difference is. And that is, once you have these models, then we start talking to them, right? And we start asking it questions, and we say, hey, tell me a story about dogs. And all of a sudden, if this was its repository of information, it'll find everything in here that has anything to do with dogs, and it could tell me a story about dogs. But if I didn't constrain the model, if I didn't say, don't do this and only do that, it can make up entirely new information about dogs that sounds like it came from a book, and it's believable to us, but it's like completely made up, right? That is an unconstrained sort of interaction with a model without any constraints. They can hallucinate, but it's a feature, not a bug. So we do this as humans, right? We could say, tell me your experience with dogs. And I might decide to be in a different mood one day, and I tell you a different story about dogs. And the same with AIs. Unconstrained, they will sound very believable and tell you stuff, and you think it comes from one of these books, but it may have taken a whole bunch of books and then said, well, I'm going to mix a lot of that together and come up with a different way to describe what dogs are, or a story about dogs once upon a time. So that's interesting. It has value in creative storytelling. It's not a bad thing. But then we learned that, okay, well, these are really powerful. I wonder if you could constrain them and you could get them to be factual. So if you get into prompt engineering, or really having a dialogue with these AI models, and you constrain them through words by saying, like, tell me a story about dogs, but only use your training data, and explicitly do not make up information that is not found in your training data, you're going to get a different answer. All of a sudden, you've constrained it just a little bit. That's what prompt engineering is. It's sort of having a dialogue with them, and you're saying, like, hey, let's rein in and control that creativity. I don't want it to be, you making stuff up. I want you to make a story up, but use the data and only the training data you have. And now you're prompt engineering. And then to go from there to sort of making an AI an agentic system, that means we're going to give it a task to go execute on. And this is more than just storytelling now. So, for example, of all the books you have, give me the ones that you think would help me learn what types of activities my breed of dog would enjoy. So, for example, we have a German Shepherd at home, and that breed is inherently not a social breed. It would say, like, don't bring it to a dog park. This type of breed was raised and is entirely different than a golden retriever, right? Back to what even a dog has a mental model. So of all of its genetics of all time being raised, and whether it's a working dog or a training dog, police dog, that's inherent in its genetics and comes through in what type of behavior it has. So now when we get agentic systems, or we're talking to AIs and we're trying to get them to be task oriented, we're starting to move into what are like agentic flows or agentic types of interactions with AIs. It's no longer just a one-to-one communication with prompt engineering. All of a sudden you're saying, now go to that library, find facts and be specific, and go, come back with this exact thing. And this becomes even more apparent if you were to like to do calculations. So maybe it's like, hey, my dog needs to eat. How much food does my dog need to eat at this weight? And it's got to do math. And now you would have a calculator, and it actually is not. It's going to get actual facts, plus it's also using a calculator to do math. Anyways, it's basically about even more constraints, and about getting this thing to go autonomously or semi-autonomously have an ability to make a choice, to come back with answers on the task. And it's probably not the best description of it, but nonetheless, to get to where we're going, I hope this at least describes a bit of a leap there, where it's now getting more constrained in one respect, but also allowing it to have some agency to do tool selection, and you can start to tell this model that you have access to not only the library here, but I want you to go onto the internet's library, Wikipedia, for example, and also access this calculator to do the math to give it back an explicit answer. So it starts to turn into giving it more freedom and constraint at the same time. That's not a really good way to describe it, but it's kind of what's happening. It's like, you can go help me answer my question, but within these types of constraints, these are the tools you're allowed to access, and then give me an answer. And moving forward, so then the model context protocol, I was looking at that and going, okay, I have to learn, everybody's talking about it, what is it? And you might just hear people say model context protocol, but they don't actually include the word server. And I don't have it on this demo here. But that's where I was like, hey, this feels a lot like an agent. And what I mean by this is what a model context protocol doing is similar to an agent. However, it's two-way. So without the word server on it, it is just a protocol, which just means an agreement into how you communicate. Two people communicate. So the English language is a protocol because you both agree that the utterances mean this, and play it back to me. Do you know what up is in this language? Yes, up, and they point up. You've had a protocol that the recipient understands what you meant by the utterance, and they can point to the sky up. But if I was to have a conversation between English and Mandarin, and I say, what does up mean? And the other person doesn't understand my language. That's in a protocol, two languages that don't understand each other, because the recipient can't play back pointing up. They're just like, what? I don't know what you're saying, and vice versa. So the protocol is to start to imply that the model has some context to communicate with an LLM or an AI. So let's go back here, and we can say, without the word server, it's just saying, wouldn't it be cool if we all had an agreement on how these systems can begin to communicate when they're accessing different things? So there's one thing to say, go out on the internet and find me information. And then there's another thing that is like, well, and there's another thing to say, not just go out to the internet, but go to my Slack server or go to my internal database and find this. So I like really putting the word server on it, because this helps draw a picture to say, it's one thing to have an agreement, a protocol on how to communicate with things. That's super valuable, right? You want to have that. You want to have a protocol to say, let's all believe that this evolution of AIs it has value, and wouldn't it be beneficial if we all agree that we're seeing the similar patterns on how we interact with them, and when we start to get them to work, we get them executing tasks. We're out of storytelling world. Like, that's fun and all, but it's like business is like, yeah, well, how can we use that? And we're constraining them, and we're putting them to work, which has value, gives you back time to be more creative and more human. That's awesome. Wouldn't it be cool if all these patterns start to become interoperable, so that as multiple systems want to be able to communicate with each other and exchange value, that we know what makes sense to how to talk to each other, what's up and what's down, and no matter who's building the systems, there's some sort of understanding between these things to have mutual value. So that's cool when there's a standardized way that says, hey, no matter if I go from this company to the next company, if I'm using a model, and I think you will see in the future, it will be like your company will have its own, Right? We're all using the big ones right now, but that's not, in my theory or my guess, it's not going to stay that way. It's going to be every company has a model. You'll have your own model, but it'll probably go here. You've got the big behemoths, then you've got people starting to use them internally because you don't want all your intellectual property leaking out everywhere. So your company will have its own model, which is what? It's all of the data inside of your company all of a sudden accessible by something that behaves like a neural network, right? And it's a different type of computation. So it's like, hey, take all my information and attach something to it that is like we can have a conversation with it. And so we have open source LLMs that are inherently biased by wherever they were made, but we can now say, well, I'm glad you can have a general conversation with me, but in my environment, I'm going to say you have access to my information. So my model is all of my Slack information, all of my customer data, everything, blah, 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 blah. And in order to have that, I'm going to develop my own model. And the model context protocol server just says, now we're going to have a repository of all my data so that when any employee at the company uses our local company model, there is a standard way that any employee in the company that starts to want to interact with all of our data, it goes through this new standardized method of communicating. Really, so it's like your large database, but your large database all of a sudden has a way to speak a new language. It's kind of how I'm thinking about it. And then that way it doesn't matter if it's a new employee or somebody's been here since the beginning. They get their open source tool. They're able to talk to your company's repository of information, but it's going through a standardized way that we know that these systems work, right? So if we understand this much so far that they hallucinate without constraints, so then we give them constraints by prompt engineering, and then we know that, hey, in order to get them to successfully execute tasks, they need to grab tools. These start to become reusable patterns. Those patterns are now far enough along that we start to write a standard or come up with an agreeable standard to say, hey, now if I go from one company to the next and I have to write a new system or interact with information in a similar way, we know that we're doing the same thing under the hood. And then that in a lot is kind of like thinking about Michael Levin's library is different than my library and is different than somebody else on the internet's library. And we could say, hey, you're in my house now, and you brought your own LLM and you're curious about everything that I've ever read. Well, hook into my library. And then imagine he had a magic way of saying, these are all my books, they've been scanned, and this is them. You would have a very unique profile of that library of information. It would be Michael Levin's model context protocol server. It's basically his repo, but you're saying we have a standardized way to talk to different libraries now. And if I was to scan my books, put them all into a digital repo and say, well, that's Ian's, and it would have my interest. It'd be very interesting. It'd be different than Levin's, different than yours, different than everybody's. We all collect information differently. And now all of a sudden we have a way, my context is different than Levin's context, is different than your context, and they all have these they all have these unique sort of just identities. And you can now have an interoperable way to show up and say, I'm going to put all mine into this new protocol, and it follows this standard so that no matter which person shows up with their their AI to talk to my um, information, it's set up, right? So that it's like, maybe, if we didn't have a protocol, and I happen to scan these all and save them as a weird format, like a text file, and Levin scanned all his and he saves his as a PDF, and somebody else over here does it and they save theirs as an Excel spreadsheet, and then all of a sudden you show up with your AI to try and say, I want to talk to these 3 different systems, and it's like, well, and it just happened to be that LLM could not understand how to read Excel data stored as Excel. All of a sudden you have problems. So the model context protocol is trying to say, hey, it doesn't matter what type of information system you have, if we all structure it in a way that works to talk AI, really, right? If we all structure our data to sort of like speak to working with AIs, then we'll have an interoperable system. So that's what I learned this weekend. Hopefully that's helpful. That's a little bit longer than what I went, and then that brings me back to this, where I believe I did put in the key now. So I built this little interactive tool so I could test a model context protocol server, and I gave it some tools, right? So it can calculate and it can search, and then it has a couple of data sources. So this is with IOG where I work, and then we have a bunch of personas about. In crypto, there's these types of identities that are, in this type of market, finance. And then we have some products at IOG. So I could ask it a question like, what products are at IOG? And if I hit send, this demonstration shows you that it's going to do some work by using a search tool. And in this example, it searched and it shows you what it did, right? I went and searched, and I went to IOG's products categories, and I found them. So I could then say, right, I have explicit recall of data and it's not made up. But this is now, like, this could grow to be absolutely massive, but just for the sake of me trying to learn and understand it, I built this real quick so that you could do things like this and I could really comprehend what it's doing. So in this example, it only went into the products, but if I wanted to say now, well, how could I integrate the personas? What products at IOG are useful for builders? Just because I know builders is a persona, it should go and look through both of these tools, and it didn't. So this is needs to be tweaked. But it basically, I got to edit this. I'm working on it right now, and it would basically show its path where it goes, oh, I went to look at products and which personas would be useful of the products, would consider the products useful based on their persona, and then show you the pathway. But I'm not done that. I'm still working on it, and that should show you it sort of like dance between these data sources, and then you can add more and more tools as well. Which another tool I have over here that I haven't added yet, but I will, is, okay, not only do I just want a calculator, now the next thing I want to do is go look at real-time data on the internet through an API that gives us the real price of ADA. So in this example, it's 63 cents. So the next tool I build is not only just search, it's also an API access to real-time crypto pricing. So then when I ask it a question, it's going and it's grabbing the actual current price, calculating it, and doing this type of thing. So that just hopefully shows you where the where this is eventually going. And I'll end there. Thank you.